Hello and welcome to this instructional video. In this video, we're going to work through how to move toolpaths that have been generated in CATIA into Vericut for verification. Through the assignments that you've been following, you've been using models that have been created for you. In this tutorial, you're going to see how to build a model. To do this, we're going to utilize a direct interface application that ties CATIA directly to Vericut. To do this too, we also need to have a model that's been created and planned. And what you see in front of you here is the model that the previous videos have been taking you through. So you don't necessarily have to have it all completed, but you should have at least a setup with some operations in it before you attempt to do this video. So just to summarize, I'm going to go here into the first setup to the very last operation just to show you how far along this particular example is. I'm going to go to the video replay button, a full video replay. I'm going to zoom in a bit. I'm going to run this. So again, if you've completed the first setup following the videos, this is what you should end up with. Okay, so the first thing that we're going to have to do before we can do the connection to Vericut is we have to slightly modify one of the parts. We're going to attach an access system to the fixed, base of the device, sorry. And this access system is going to allow us to be able to connect the CATIA model to the Vericut model. So to do this, what we're going to do is we're going to go into the first setup product, which is this here in the product list. We're going to expand this out. We're going to go into the subassembly for the Kurt vise, and I'm going to move down to the base. And I'm going to right-click on this, and under Object, I'm going to open it in a new window. So here's a picture of our vise. First thing I'm going to do is I'm going to make sure that it's lined up correctly. So the way the vise is going to be on the machine is the handle is going to be here, the fixed jaw is down here. So to the left here is going to be the x-axis of the machine tool, the y-axis this way, and of course the z-axis is vertical. Notice that I'm now in the part design workbench, and what I'm going to do is I'm going to come up here to the insert menu, and I'm going to insert an access system, and then there's a definition window that pops up that allows us to insert that access system. So the first thing we want to do is define a point for the access system, so the origin of the access system. I'm going to right-click on this, and I'm going to create a point to do this. There isn't a point where I want to actually place it, so I'm going to have to create a point. And you have the point definition window appears. I want to create a point that is at the center of this hole. This is how the vise is tied onto the machine. So what I'm going to do is I'm going to toggle this to center of circle sphere ellipse, and then I'm going to click on the circle so that this point here that I'm creating is going to be where the origin of the access system is. So I'm going to hit OK. The access system is created by default. I want to make sure that this access system, however, is aligned with the machine tool access system so that when I move the model into Vericut, it lines up correctly, it's oriented correctly. So the x-axis here is actually pointing in the wrong direction because the positive x is to the right. Sorry, this is the x-axis here, so it's not even aligned with the x-axis. So I have to realign these. What I want to do is move the z-axis to the vertical, and I want to rotate the x-axis so that it's pointing along left to right on the screen. And I'm going to use the compass here to help me do this. So the x-axis, what I'm going to do is I'm going to change it so that it lies along the negative z-axis. So I'm going to right-click on x-axis. I'm going to go down here to coordinates, and this allows me to specify the x-axis as a set of coordinates or as a vector. And I'm going to change this so that the vector lies along the negative z-axis. So that would be 0, 0, -1. So notice now that the x-axis is now aligned along the z-axis. And then the next thing I need to do is change the z-axis, which is now pointing along the positive y direction, or sorry, positive x here. I want to rotate that so that's lying along the y-axis of the compass. So again, I come to the z-axis here, right-click, go down to coordinates, and now I want to change this so that it's along the y-axis. So the coordinates are going to be 0, 1, 0. And there we go. We now have a axis system created, which is centered on the hole on the bottom, and where the x-axis lines up with the x-axis of the machine tool table, and the z-axis and y-axis similarly. So I'm going to hit OK here to accept this. The other thing that's useful, if you go into the tree here, notice that there's now a collection called Axis Systems. I'm going to expand this. I'm just going to right-click on this and go to Properties. And I'm just going to rename this. I'm going to call it Attach Axis System. Just so I know that that's the system that I'm going to use, the axis system that I'm going to use to attach device to the Vericut model. So now that we have the axis system attached, I'm going to go back to my process file. So you can use the Windows and go back to that. Notice that if you look in the model here, you can see the axis system now clearly positioned. And this is a representation of the machine tool table. And you can see that it's on the interface between the base of the device and the machine tool table. So that's good. Okay, now that we have this axis system set up, what we're going to do now is we're going to activate the interface that links CATIA to Vericut. So I'm going to go down here to the Start menu, and I'm going to type in CAT, and you should see down here something called CATIA v5 Vericut interface. That should pop up. So go ahead and click on this. And you should see the interface window appear. So this interface window requires you to specify certain things to allow the model to be created automatically in Vericut using the information that you have in CATIA. So the first thing we want to do is we want to go ahead and specify a folder for where the new files that are going to be generated are going to be stored. So when you, of course, build a Vericut model, a whole bunch of new files are created, and this folder is where those files are going to be stored. So one needs to specify this file. I would point out that you may find that some of these fields are populated with information. You should check through all of these to make sure that the information is correct. So don't assume that this information is correct. So I would recommend that you place your Vericut files in the same folder or in a subfolder to the folder where you have your CATIA model. So for example, in my case, this here represents the folder where I have the CATIA model that you're looking at. I'm going to just create a new folder here, and I'm going to call it Vericut Files. So it's a subfolder of the folder where the CATIA model is, and this is where I'm going to specify Vericut to place all the files that it's going to generate as part of the model that it's creating. So I need to make sure that that is in this field here. I can go ahead and click on this folder here, but since I'm pretty much almost there already, I'm just going to scroll to the end here and just type in /Vericut files. Again, I could just click on the little folder here and navigate, in the same way to that location. Okay, the next thing to input is the base name for the new files. So the Vericut files that are going to be created are going to have to be named. Notice by default it's used the same name as the CATIA model, and you can leave it as such if you want to. So in this case, I'm going to leave it there. The next thing to indicate is the project template. So we have built a project template which has all the information about the machine, the controller. You've been pretty much using this for your other assignments. So we're going to go here and navigate to that project template. So I'm going to navigate to that folder where we have created this template for you to use. This is on the N drive under the course folder. So under Student Resources, Manufacturing, MFG 332 Course Materials, Verification, Milling Models. The folder is CAT v5. And then we're going to use the VF2 process template 2.vc Vericut project.vc project. So let's highlight this and open it up. So we're going to use that as our template to build the Vericut model. The next step down here are the part operations. Notice that setup 1 and setup 2 are checked off. If you go back to the CATIA model, you can see that there are two setups here. So the interface has pulled in information already from the CATIA model indicating what setups are going to be applied. It's typically best to do this one at a time, to do your verification one at a time. So I'm going to unselect setup 2 so that we do the generation for setup 1 first. So that's the part operations or setups that are going to be simulated. The setup template is the same as the project template. You can have your setup template in a separate Vericut file, but we are going to just use the same template as our project template. There we go. Moving downwards, we want to generate the tool library from CATIA information. So what this does is it generates the tools in Vericut using the tools that were used in the operations in CATIA. So this is one of the nice things about the interface. It makes it very easy for you to create tools. You don't have to go in and create separate tools in Vericut. It's all generated automatically from CATIA. Okay, so the next step now is to tell the interface where is the access system. This is the access system that one is going to generate the toolpaths from. So this is really the machining coordinate system, which is shown here. So we're going to reselect this because this is set for part operation 2. This is part operation 1. So I'm going to click on the arrow here and select this. And the interface goes away, but if you come down here and bring it back, it should show you now that this has been reset to part operation 1. So that's the machining access system that's going to be used in Vericut. The next access system is the attach access system, and this is the one that we created at the beginning of this training video. So we want to go ahead and click on the arrow and select this access system here. So this is what Vericut's going to use, or the interface is going to use to help position the device in the model, Vericut model, when it's created. Moving downwards, almost to the middle of the interface, this is our post processor. So if you recall when you were creating your setups, when you defined the machine in CATIA, you set up your post processor, or you selected it. You have to reselect it here with an interface. So the interface allows you to select the post processor independently of what you may have set in the machines when you defined the machine in CATIA. So in the same way, we're going to have to navigate to a folder. So I'm going to click on this folder here. And the post processors are in the course folder. So if you look up here at the at the path here, you'll see that it's student resources, MFGE, ET136. So that's a little bit different. So let's go ahead and just navigate there. So let's double click on student resources, manufacturing, ET136. And then we're going to go into our CATIA folder, manufacturing, and then we want to go down here to IMS-PAR. So IMS is our post developer, and then here we have a whole bunch of posts that have this .lib extension. So the one that we've been using, or the one that we'd like to use for this class, is this post here, hasvf mod 19v6 underscore ims3.lib. So we're going to go ahead and select this, and we're going to hit open. So now this here is the post that's going to be used to convert all the operations, all the toolpaths in CATIA into GNM code. The next step is to tell the interface what parts are our design, or what part is our design, what part is our stock, and what elements do we want to go to have moved over as fixture elements. So notice that there are elements already selected, so I'm going to go ahead and highlight and remove. So this first button here allows you to remove, this button here allows you to remove the X. And I'm going to go ahead and click on the arrow, and the design, of course, is, if we come down into the tree here, is this, let me hit retry here. is this prismatic _1. So it's under the product list under the first setup. So the interface has an irritating habit of disappearing. But notice now that it's reselected here. And I'm going to do the same thing for the stock. I'm going to just highlight and delete the stock. So the same thing for the stock. I'm going to remove this just in case it's probably not the right one. I'm going to click on the little arrow here and then come down here and select stock 1. Again, the window disappears. I'm going to bring it back. The fixturing elements, so the elements you want to pick to import into Vericut would be the base of the vise, the moving jaw, the fixed jaw, and the 2 parallels. So let's go ahead and do that. I'm going to just pick the base to start. So click on the arrow, base. Actually, let's remove these first, sorry, so that we make sure that we're reselecting. You just have to do this the first time. I'll show you in a minute that you don't have to do this again. So let's go ahead and make sure it's clear. Let's go ahead and click on the arrow, pick the base. You can see that the base has been added here. I'm going to go ahead and select the moving jaw. I'm going to select the fixed jaw, which is visible over here. I'm going to go ahead and select the 2 parallels. Okay, so we now have gone ahead and we've defined the final design. We've defined the stock. I hit the final design. Let me bring it back. And then we selected the fixture elements. We're almost done. There's really nothing else here to do. This here indicates that G code is going to be generated, and it's going to be generated using this post processor here. And this is going to be the name of the file so that you're generating. So this is going to end up in the same folder as the folder for new files up here that you selected at the beginning. Okay, so let's go ahead now, and one other thing you can do is you've put all these settings in, and I mentioned a few minutes back that you don't have to keep doing this, or you don't have to do this every single time. This button here allows you to save these settings to CATIA. So in other words, they get saved into the PPR tree, which means that every time you open up this CATIA part and run the interface, these fields automatically get populated with the information, this information that was previously stored. So that's a really nice thing about this. Once you do it once for a given CAT process file, it's within that CAT process file, and you don't have to keep doing it over and over again. So I'm going to go ahead and save this information to the PPR tree by clicking on this button here. And now I'm going to go ahead and generate and run. So this button here is basically going to generate all the files. It's going to run the post processor to generate the code. It's going to open up Vericut. It's going to load in the Vericut model with all the components, hopefully positioned correctly according to the information we put in here. And the model should be ready to simulate. So let's hit generate and run. You see this window appears here, which says that CATIA, the interface is generating files. So it goes to, generates parts for the stock, for the final part, for the fixture elements, and now it's generating the NC program. Now it runs the post processor, and you should see this runtime message window pop up, which allows you to put the program number in. This is similar to the window that pops up when you run the post processor directly in CATIA. I'm not going to change the number. I'm just going to hit continue. And what you should see happen, it's happening on my other display. Vericut is being launched. And now it's open. I'm going to move the window over so you can see what was generated. So again, this is the machine that we've been working with throughout the term for the different assignments. If you zoom in, you will see that the Kurt vise has been generated in the model, and the vise has been positioned in the center of the table using that attach access system that we created in the CAT, in the base CAT part. Also, too, if you go to the tree here, if you expand it out, if it's closed, expand out the setup under CNC machine. If you go to the attach, you'll notice that under models, fixture models, we have all the fixture elements that we selected in CATIA were imported, the base, the fixture, the moving joint, the two parallels. We also have under design, under models, we have the model. The model is actually hidden because what we're seeing right now is the stock model here. So if we were to right click and make this temporarily invisible, we should see this is the final part geometry there. So all this has been generated automatically by the interface. So I'm going to bring back the stock. The other thing that's been done automatically too are the tools. So if we go down here and double click on the tooling, you should see, I'm going to move this over to the tooling window. And in the first setup, we only used 3 tools. Made a mistake and forgot to renumber the center drill, so it has this large number. But these were the 3 tools that were generated automatically from the tools that were used for the first setup. So again, a really great time saver. You don't have to create these yourself in Vericut. And then there are coordinate systems that were created too. So the default machining axis for the part operation, this is actually hidden right now. So if we make it visible, we see that it's positioned top right hand corner, which is the same position it was positioned in CATIA. If we go ahead and double click on the manufacturing program, this is the code that was generated automatically by the post processor. You'll notice that there's some missing information here in the comment fields. This is because you are going to have to go in there and put that information in yourself. The post isn't smart enough to do it, the post processor that we set up. And then there's some other information down here that you have to also pay attention to. But again, this is the program that was automatically generated by the post. Let's go ahead now and simulate. So I'm going to go ahead and hit the play button just to see what happens here. Pull the part over. So again, the sequence of operations is the facing operation. So roughing and finishing pass. Speed it up a little bit so that we're not here all day. Oops. Here's the profiling operation. Now we're into the engraving operation. And then finally chamfering operation. So if I switch my views to see a dual view, so I go to the view up here, go to a 2-view layout. This here shows the the workpiece view, the machine view on the side. Right now you can't really see the cut stock because the design, which is brown, is showing true. So I'm going to go over here and hide temporarily the design. And when I zoom in, I can see more clearly the cut stock. So the engraving that was generated, which you were able to see in CATIA too. So in summary, this kind of shows you the steps that you go through to utilize the CAT-V interface, so the CATIA Vericut interface, to automate the creation of a Vericut model, utilizing templates that we've created, and utilizing information in the CAT process file to help build this Vericut model. If you go back to CATIA, of course, you could repeat this for the second setup. So let's go ahead and do that just to show how you can quickly generate the toolpaths for a second setup. So if I click on the second setup, the model disappears because I've hidden the second setup. So I'm going to unhide this. And then I'm going to hide just temporarily the product for the first setup. So here's the second setup. Let's go back to the interface. I'm actually going to just close down CATIA here, not CATIA, Vericut. So let's assume we've finished with the first setup. We're going to close this down. I'm going to Save check files. Let's go back to the interface. So we want to now unselect setup 1, select setup 2. And what's different here? Well, we need to, first of all, change everything up here is going to be the same for the most part. What we're going to want to change, though, is we're going to want to change the default machining, the stock access system. We want to make sure that we pick the machining access system for part operation 2. So let's go ahead and reselect this. The other thing that we're going to have to change is, do we need to change the attach access system? No, this is the same access system that we used for the first setup. However, just to be sure, we're just going to reselect it because sometimes things get messed up. So let's go ahead and just reselect this. And then the design, although it's the same design, it's oriented differently, and it's actually a different model in the tree. So remember, we selected the previous design and stock from this product. So let's go ahead and delete this. Highlight, delete, highlight, delete. And let's delete all of these here too. And then what we're going to do is just reselect the design. We're going to reselect the stock. Now the stock is different, so we would expect to pick up a different stock model. And then the fixture, again, these are the same fixture files, but their position might be different for the second setup. So let's make sure that we reselect them too. So we select the base, looping jaw, fixed jaw, the first parallel, and then the second parallel. Okay, so we've now reselected everything that we've needed for the second setup. Let's go ahead and save this to the PPR3. So this saves this information, but it saves it under setup 2. So again, this is saved. We don't have to do this. If you've done it correctly, we don't have to do this a second time. So let's go ahead now and just rerun, or generate and run. So we're now generating and running for the second setup. So again, just as with the first setup, we should see this CATIA CatV saying it's generating files. So now it's on to hosting the second setup. So now it's generating GNM code for the second setup. And we have our window here as before. So let's make this 2000 for the second setup. Continue. And again, Vericut is launching. It's launching on my second display. Should be up in a second. Here we go. So again, we see the vise, the fixture elements. We see the part. The stock's invisible. I actually made it invisible in CATIA, so it's invisible in Vericut. So again, if you go to the setup and work your way downwards to the attach and fixture, you can eventually get to the stock and make it visible. And notice that the stock is different because the stock is the shape of the workpiece after the first setup has been removed. So that was done in CATIA actually. So here's our second setup. Let's go ahead and simulate it. See what happens. See as before. I'm actually going to bring in a double window so we can see the workpiece view at the same time as we are seeing the machine view. Let's continue. So here's our facing operation. So there were a number of passes that we had to take on the second side. Let's speed things up a bit. Notice that there were some collisions there, so probably approaches that weren't correctly set. So again, these are things that one would have to go back and fix. So again, this is where Vericut gets to be really helpful. Again, there were some more over here. And most of these will probably go away with some changes to the approaches and retracts. Okay, not quite done. We didn't get to the center drilling. Some kind of boring, sorry. So yeah, there are quite a few things that need to be fixed here. All these error messages, fast read rate, indicate things that need to be fixed. And more than likely, there are issues that had to do with the approaches and retracts. And again, double-clicking on these will take you to where the problem is in the code. And this is really important here to be able to double-click, because remember, this code is CATIA generated. Notice how many lines of code there are in this program. If I go to the bottom, it's over almost 7,000 lines of code to machine this part. So there's a lot of code in there to deal with. So again, in summary, this is the interface from CATIA to Vericut. Allows you to automate the creation of a Vericut model, to generate your code and to quickly simulate that code. Really very helpful in terms of automating the time or reducing the time it takes to be able to verify your CATIA toolpaths. Thank you.